my talk. It is titled Building Multi-Factor Authentication into Your Applications. But first, why should you listen to me? Let me introduce myself. My name is Nathaniel Okenwa, and I am a Developer Evangelist at a company called Twilio. For those of you who may have never heard about Twilio, I'll just quickly tell you what it does. Twilio is a cloud communication set of APIs so that developers like yourselves can use the languages that you know and love and implement communications into the applications you are building. What does this look like practically? This might be like sending a text message, sending emails, WhatsApp, making voice calls. I can almost guarantee you've probably actually used Twilio, but you didn't know it. Maybe you've needed to do a 2FA message at some point, or maybe you've received a phone call from your ride sharing service or your delivery service. Chances are it was Twilio that made that happen. And lots of people use our APIs to handle two-factor authentication. And because of that, we have learnt a lot about some of the really good things that you should be doing and some things you need to watch out for when it comes to two-factor authentication. And that's what I'd like to talk about. But also, if you do want to just chat to me about two-factor authentication and more, or you just want to maybe talk to me about some of the things that I love, some of my hobbies, feel free to hit me up online at Chatterbox Coder as well. All right, let's go into this. Now, one thing I want to say is, as well as all the other hobbies I list, I am a huge fan of movies, especially classic movies. And one of my favorite classic movies is the movie called Blade Runner. It came out in 1982. And in the movie, a Blade Runner must pursue and terminate four replicants who stole the ship in space and have returned to Earth to find their creator. Now, the main character is played by Harrison Ford, and his name is Rick Deckard. And so his job as the Blade Runner is like a kind of police officer. And his job is to track down these bioengineered humanoids, the ones that are called replicants. Now, the humanoids look, act, talk almost exactly like humans, and it's very, very hard to distinguish between the two. And oftentimes, these replicants, they actually do crimes or have risen up against humanity. Classic robot stuff. And his job is to track down four of them and to permanently tire them. But the reason why I bring this up in today's talk is because even way back in 1982, humans foresaw a world where people would find it difficult to distinguish between humans and computer programs, like the replicants. And this brings me to another name for my talk. I really like this name for my talk, which is 422 Unprocessable Entity Suspicious Phone Number. And the reason why I kind of like this as my backup name for the talk is because 422 is a status code. We're at API Day. So you may have built an API that sends a 422. And oftentimes you may send a 422 when the request you received was a bit suspicious. Maybe there was something about it that wasn't just right. So usually it's for unprocessable content or entity, and this means the server understands the request but won't complete it because of some semantical problems. And oftentimes you might return this status code when you don't trust them. We return this status code, our APIs return this status code if a phone number looks maybe suspicious. Now, let's talk about some of those suspicious numbers that may be occurring and hitting your two-factor authentication. Well, first of all, they could be fake or spam users. These are the users that create spam or create undesired content and can cause distracting data points. And then you also have hackers or bots, and these people, not people, but these users are definitely trying to crawl your data, maybe look for security holes. They want to take advantage of you, or maybe take advantage of your customers, and they want to do harm. And we want to keep them off our platforms. And two-factor authentication is one of the ways that we can go about doing it. But why do we use two-factor authentication? Well, back to the movie Blade Runner. One of the things he does when he finds a person that he suspects is a replicant and not a human is he takes them into this room and sits them in front of this machine. Now, hopefully I don't butcher this name, but this machine is called the Voight-Kampff test, and it's designed to distinguish replicants from humans based on their emotional responses to questions. So what Harrison Ford's character would do is he'd be asking questions to the human or replicant, and based on their responses, he will be able to tell if they were human or replicant. Again, way back in 1982, they foresaw this problem. And today, in the modern world of the web platforms that we're building, that you're building, maybe the web platform that you're using to serve your API. So when people log in, they can go in and change their settings and do all sorts of things. Maybe you have a web platform for end users. You want to identify those real users and determine which ones are real people that you want to be using your service and which people you want to keep out. Maybe those are bots or maybe computer programs that you don't want. And oftentimes, some of the classic ones that we've used are captchas. I find captchas hilarious because they're getting so ridiculous. And I won't be surprised if there's a point in the near future where only computer programs will actually be able to decipher captchas reliably. And another thing, which is kind of going to be what we talk about today, is sending one-time passwords. Now, this isn't perfect and it can be very hard and expensive to do at scale. I'm sure most of you have gotten one of these SMS messages before. Think about some of those situations because we're going to talk about that a little bit more. Uh, just before we move on, I also do want to shout out one of my favorite captchas that I've seen in the wild about the spiral galaxy. While I know there is the answer in the top right, they're getting really, really hard to distinguish. But anyway, let's think about this user verification, figuring out whether this person is a real person that we want on the platform and they are who they say they are. So we have this user verification as part of the customer journey. I say customer could be user. It may not necessarily be the person who's paying, but the person who's using your platform. And you probably use them to verify users that sign ups, especially in some industries such as finance, where knowing your customer is part of regulations. You may use user verification and use uh, maybe their phone number as a way to verify that they are who they say they are. And then after they've registered, you may use it to protect login so that when people log in and sign and want to do actions on your platform, you know that they are who they say they are. And then also authorizing maybe high level transactions. So I often saw this in the finance space where if you wanted to maybe make a large transfer, there would be an extra 2FA check to make sure you are who you say they are. Now, those of you who maybe know a little bit about Twilio already might know that you can use the Twilio messaging API to send text messages. And you're maybe thinking, wow, yeah, I know the Twilio APIs, or maybe you have another provider's API, and you can go, okay, it's just like 2 lines of code to send a text message with a code and then confirm it. And you may be right, but it's not actually that easy because building your own one-time password infrastructure can be very, very difficult. There's additional dev requirements that you have to add. Also, it can be costly in some countries, especially if you're working on a global scale. There's lots of regulations in different countries, and then also there can be security gaps. Unfortunately, bad actors are not staying still. They're constantly innovating. And I'm going to talk about one of the, I don't like calling it innovations, but one of the new ways that bad actors have been targeting people who use 2FA recently. Now, this is a new scheme called SMS pumping. And this happens when fraudsters request one time passwords over and over again in order to just generate SMS traffic for which they are incentivized by small local carriers. And I'll explain what it means. So you have a fraudster. Bad person. We don't like it. And then you also have a mobile network operator. Now, these aren't usually the big ones that we may be familiar with, but oftentimes these may be smaller mobile network operators that often have premium phone numbers that would charge more to receive a text message. You may have come across a number in a wild where if you wanted to send a text message or call that number, it's going to cost you way more than usual or way more than it would cost you with other services. So this mobile network operator has these premium numbers that they would like people to create traffic to, whether it's phone calls or text messages. So This mobile network operator creates a revenue share. So they tell a fraudster, yo, fraudster, if you can somehow make lots of text messages suddenly show up to these phone numbers, I will give you some of the money that I make from that. And so now the fraudster is incentivized to go and find an application that is going to freely send text messages to a number that they have. And this might be your application. And your application might just be using this for one time passwords, for security passwords. And they don't care. They just go and trigger lots of verifications to those premium phone numbers, and the mobile network operator makes money and shares it with them. The person at the end of the day who's left with the bill, fortunately, is you. And that's not good. And if you don't believe me, there is a massive example of where this can go wrong. You may remember that they turned off 2FA for free users for a while, and this was part of his justification because they were losing a lot of money. And it's not just Twitter or X. This damage goes into billions every year. In 2019, we saw that there was like what $3.1 billion worth of fraud on new accounts. And there's estimated to be over $100 billion worth of fraud in telecoms fraud by 2023. And you want to avoid. So if you do your 2FA wrong, it could cost you a lot of money. If you do it right, it saves you money, secures your users, and it gives them a good experience. So what do we need to do to make sure that we do this right? Well, let's first talk about spotting fraud, looking out for those fraud indicators. One thing you can keep a lookout on is conversion behavior. Are people who start a verification process, start and ask you to send them a one time password, are they actually putting that one time password back into your website and completing that process? Remember, those fraudsters, they don't really care about completing the process and getting approved to log in. They just want to trigger as many of these as they can. And oftentimes, when you look at, you need to monitor your OTP conversion rate. See if there are suddenly lots of lots of messages being sent without those codes actually being put back into your platform. And remember to detect non-human behavior. Sometimes you can do things like try and see if these are all coming from certain IP addresses, or you can check the user agent of the browser that is actually making these calls. And you can try and do some things to make sure that doesn't happen. Also, you should watch out for traffic spikes. Now, obviously, we all would love to be able to scale, and scaling is good, but sometimes a spike can be a little bit suspicious. So, watch out for spikes in account activity that don't really make much sense, especially if they're maybe country specific. Maybe they're in a country that you don't really serve. You shouldn't have a sudden influx in customers there. It might be a bit suspicious. Also, a lot of these fraudsters, remember, they're working with mobile not network operators. They may have a bunch of numbers, and the numbers all start the same. And maybe you could almost look at the last numbers, the last digits, and they almost increment. And sometimes that could also be a clue. And then also unexpected destinations. You don't serve a country, and suddenly you're getting 2FA requests from that country. A little bit suspicious. And then another thing you can do is maintain a carrier ranking. So, keeping an eye out on all of the different phone networks, figuring out which ones are good. So, for example, some of the big ones that we all know about, you'd be like, these ones are safe. If we're getting a 2FA request from them, it's probably a real human on the other side. And then you maybe get ones that you are a little bit more suspicious about. It's a lot to do. Now, another thing you could do is just bypass SMS altogether and use a different channel. So, one of the popular channels that lots of people use is email. Because SMS pumping just doesn't exist in email. And also, everybody has an email account these days. There's such a strong user adoption. There are a few cons, I must say. First of all, usually a password can be reset via an email. So once the email is compromised, their whole account's compromised. It doesn't end up being a second factor separate to email. So there's a little con there. Another channel that is becoming really popular that we are seeing is WhatsApp. So you already have their phone number. There is a high conversion rate. It's second factor, and it works pretty similarly in the end to the way to the way SMS works. And then also, you won't get charged maybe if the message isn't delivered. Also, it's really, really popular in certain countries. So, for example, in Brazil, in certain parts of Europe, WhatsApp is very, very popular, maybe even more popular than SMS as well. So, WhatsApp is maybe a good choice. But what we see here is we have lots of different options, and combining all of these factors can help you be really, really safe. Let's actually talk about a couple of other options. So we've got these ones which are kind of all communications. I just want to quickly talk about some of the other ones. So you may have heard, you may have an authenticator app. I use an app called Authy. There, where you have one-time passwords or timed one-time passwords. These work with keys in the background behind them, and they're really, really good, really, really private, really, really secure. You bring your own app. One thing I will say about this is, among maybe people who are very, very technically literate, lots of these people may have them, they are not as widespread adopted as maybe like a WhatsApp or an email or an SMS. Not as many users have one-timed or timed one-time password applications on. There are also some new things coming out. So, for example, we've been really, really excited to work on Silent Network Auth. Where we're using the secure carrier network technology. So, essentially, the technology that mobile network providers use to bill their phone network usage. So, it's really, really secure. And we are looking into how you can use it for verification. We actually have it in beta, so you come check it out as well later on. As well. So you've got all of these different kind of choices in the platter of multi-factor authentication options. And lots of people, though, when I talk about these different things, they go, well, why don't we just use authenticator apps? They're the most secure. Yeah, on the face of it, they probably seem most secure. There was some research done by Google a while back, and they actually put out different. They looked at account takeover and preventing it by different challenges. So a challenge will be like, for example, an SMS, which is like, "Is this you? If it is you, here's the code." So if it was an on-device prompt, it was like really, really good against automated bots, really, really good against bulk phishing attacks. Against a targeted attack, it was pretty solid, 90% with a confidence interval, which is quite wide. Decent. When you got to SMS codes, you still got really, really well against automated bots. Decent against the bulk phishing attack, against the targeted attack. That's where you saw it kind of drop its score. And then security keys, just they were top 100% all the way. Right. So people I could understand will be like, we should only use security keys and one-time passwords and timed one-time passwords. Those actually end up being security keys in the background. And I agree with you. I get where you're coming from, but I think there's another layer that we need to do. So I went and found a paper behind this research and dug a little bit deeper. And they had this whole chart where they got this kind of data from, but this one talks about the pass rate, skip rate, abandon rate. And these three things talks about how many people, when they're challenged, were they actually did it completely because they were familiar with it, so it was successful, or how many people were unfamiliar with it and it wasn't successful. And what we noticed was that when people were unfamiliar with the type of when people were unfamiliar with the format of the challenge, they were much more likely to skip it, much more likely to abandon it. And we can see there were some really, really big numbers, especially when people are unfamiliar. 30% of people would just skip it, 34% would skip the like settings OTP, which is a kind of like the keys. People who are unfamiliar, 48% would just abandon it. And oftentimes these abandons and skips turn into someone trying to turn these security features off on their platform. And what does that tell us? Usability is imperative. Whenever security introduces too much friction, users are more likely to skip, to abandon, or turn off these security features, or even worse, they may want to go to another platform because of it. I saw this Slack once and I asked the person's permission. I've blanked them out, but I loved it. Like my personal email provider is way too intense about getting about 2FA. Getting hacked should be a risk I'm allowed to take. Another person wasn't seriously saying that they wanted to be attacked, and they weren't seriously saying that they didn't care that their email company cared about their security, but they had a certain amount of risk that they were tolerant to and the amount of usability that they required. And it ends up being a balancing act between the two, risk and making sure things are secure, but also keeping things usable, especially for a diverse set of users, not just people who are familiar with all of the latest and greatest in technology. So, something that I think could maybe help you to figure out how to balance both of these is what I call the bank security model. It's not trademarked, so you can feel free to copy it. So the bank security model is I try to find real blueprints for a real bank. Unfortunately or fortunately, you can't really find those online. So I went to a video game called Payday, where you try to break into a bank and steal stuff. And so here are my fake bank blueprints. And but even though they're fake blank blueprints, most banks, especially bigger ones, have a similar kind of vibe. And they have these three kind of key areas that I would like to talk about. Now, if we think about the whole bank as as your application, a whole bank is secure. You probably have a security guard when you come in. You have CCTV covering everywhere. The bank itself is pretty secure, but even within the bank, there are different levels of risk tolerance. For example, the bank tellers who sit right at the front, they are where the high risk frequency and low risk activities happen. They have a amount of cash in their registers in front of them. They get users verified quickly. This might be when people log in to your platform, or maybe when they register and sign up. You don't want to add too much friction here because you want them to be able to do these tasks regularly. They're going to need to do them quite a bit. But then there are times when people want to do actions that require an extra level of security. This is where I say, this is where things go in the vault. This is where there are higher risk activities, and you want to prioritize a more or even the most secure form of authentication. You want to keep things extremely secure. So, this is where you need to look at your platform and look at the activities that users are going to be doing on your platform and decide what needs to be with the bank tellers, what needs to be in the vault. And one step above the vault, you might have the safety deposit box. These are the highest end of security because, I mean, even though they're in the bank, in the vault, you still need a security key to open them. And this is the highest risk. So, this would require lots of user education. The friction here is actually a plus, it's part of the experience because it's such an important thing. And what you should do is look at the different actions people will be taking on your platform and figure out which one of these places should they fit. That will help you decide what form of two-factor authentication you want to use. Now, an example of a company that I think does really, really well with this is GitHub. GitHub, if you go onto your GitHub page, if you maybe have one and go into your settings and go onto your 2FA, you actually see that there's multiple methods of authentication. You've got Authenticator app, you've got SMS, you've got GitHub Mobile, you can have recovery codes if you need to get everything back. This is my one, and as you can see, I prefer the GitHub Mobile as my preferred 2FA. It is honestly awesome. But then sometimes there have been times when, for one reason or the other, I couldn't use GitHub Mobile. I have my Authenticator app. I have it as well digitally on my computer, so I could use my Authenticator app, which was quite useful to switch between the two based on what I was doing. But here we can see that GitHub has given me lots of choices on the different forms of authentication. This is something that I highly recommend you should do. But let's go to building it and adding it into your app. You might be thinking to yourself, well, now, Nathaniel, I've got to build an application and like a whole way to do security for SMS and text messages, but I need to do a separate one for authenticator apps. I need to do a separate one for maybe our app and using our own in house app for verification. And yeah, this is where I'm going to talk a little bit about Twilio and Twilio's API for two-factor authentication called Verify. Twilio Verify is one solution for all channels, and it's all about finding the right mix while keeping the requirements for your engineers as low as possible. And so, let me just give you an example of what this might look like. So, you have a verification request going to your backend app, and your backend app may go and send a request to the Twilio Verify APIs. And you would have some information about where this request is coming from. Is it coming from a web browser on a computer? Is it coming from the mobile app? Where is it coming from? What is the user trying to do? And then you can decide, okay, based on these things, we're going to maybe prioritize first that we're going to do biometric authentication or silent authentication from the mobile app. That's our base case scenario. Oh, the person doesn't have the app installed. Okay, we'll fall back. Do they have one of the authenticator apps that we've got set up? Yes, they do. We can just do a notification there. No, they don't. Okay, maybe they have a token with a timed one-time password. They don't. Okay, it is a low security event. We are going to fall back to SMS or maybe WhatsApp or even email or a phone. And you can see here how you have all of these options and you have one API that can do it all for you. And you can just grab some information about where the user is kind of coming from, what they're trying to do, and use that with our API to decide where you want to send the verification request to. All right. So, I mean, I've talked about this and I've sold a big game about this API. Why don't I actually show you what I. All right. I'm going to jump into code. Give me a second while I just make sure that my computer is all in the right space. All right. So here I have a website. And on this website, I can log in. It's my cookie website. I really like it. I really like my cookies. And I can just click in with my username and password, and voila, I'm in. The first thing we're going to want to do is implement SMS. Now, I am not going to actually write code right now. I don't have enough time. But what I'm going to quickly do is I'm just going to check out to my SMS branch, and I'm going to show you what's going on here. So here, when the person logs in, we're first of all checking if their password is equal to the guess. So if they had a correct password, you would probably have your password encrypted and not your password wouldn't be in a data.json file, which is just a fake database. Okay, you wouldn't do it like this. But what you would do is once the password has been seen as correct, you will create a verification. Here, this is the actual call to the Twilio Verify API. We're just saying, hey, there's a verify service. Can you create a verification to this user's phone number over the channel SMS? Now, you also need to do a bit of some front end things to make sure that your application is also going to pop up a prompt. And then I should actually be receiving a text. I just received one right now. Let me pop it in. That says, oh, my verification code is 395448. Hey, it works. This is kind of good. I've got 2FA, but it's really, really bad when we think about the SMS pumping situation. With SMS pumping, now a website who can crawl a bot can just now go and hit this over and over and over and over again. So we want to protect ourselves from SMS pumping. There are a couple of things we need to do. So first thing we're going to do is we're going to implement Retry Logic. Now, what we want to do is we want to make sure that we can stop bad actors from just spamming one-time passwords, but we also do want to give real users the opportunity and the ability to send another one. Maybe if the first message didn't go through, maybe something went wrong. Sometimes things go wrong. They can just trigger another one again. So I'm going to quickly switch to a branch that includes this retry logic. Let me just quickly show you in code what's going to happen. So this time, what I'm doing on the not in code, sorry, on the platform. This time, now is I'm still going to send the code, but you can see here we've got this resend code in 20. It was 30 seconds before, and it counts down. And until then, I can't click it. Now this is very important because you're still letting your user know, y'all, I will let you send a message, another one-time password in 30 seconds, but you're gonna have to wait. Now, your user sees this and goes, "Oh, I just need to wait 30 seconds." You may want to tweak the time based on what you're doing, and that's totally fine. So now I can hit retry. One thing is, if I hit retry, it now goes to 60 seconds, 9 seconds, and it would be exponential retries. Let me just quickly pop in the code so that I can move on with this. There we go. All right. So we can see that working, right? We can see that. Sorry, give me a second. We can see that working. We can see how you can then have these retries slowly, uh, pausing and slowing down your user so they don't just spam you. And at the same time, it protects you, protects your application. And by protecting you, it protects them. Now, even though you do this on your front end, you're still going to need to do quite a bit of things in your back end. You're still going to need to look up. Remember what I said about all of the fraud indicators? You've got to look up where things are coming from, where things are going. You need to keep an eye on how many times they've tried. You look at retries, you look at attempts, you're going to look at like the phone history number of where it came from. That ends up being quite a lot. So let's actually just talk about an easier way that we can work through that. I'm going to quickly show you the Twilio platform and a tool that we have called Fraud Guard. So this is what I've been using so far. You can see here, I've got SMS, I've got WhatsApp, I've got email, voice, push, timed one-time passwords as well. We're going to just go to SMS and see here, we've got something called Fraud Guard. And just by turning it on, I am now having Twilio take on lots and lots of this hard work for me. Twilio looks at traffic not just on your platform, but across the millions of platforms that we serve and goes, this one time password from this suspicious phone number that maybe has done some shady stuff in the past. We're going to block it and we're going to let you know, yo, I don't think you want to be sending one-time passwords to this number. It's probably an SMS pumping scheme. You can also choose how much risk you want. So again, there's a lot more things you can do. You can ask it to return the line type and the carrier information so you can find out more about the person. You can have landline validation to make sure you're not sending SMSs to landline numbers that can't receive them, and so much more. Now, you could try and architect this yourself, but that's a lot of work. Just make it easy for yourself. All right, so we can see how we're protecting ourselves from SMS pumping. We're doing it in a couple of ways. First of all, we're building some practical stuff in our actual front end to protect our users so the users still feel like it's a good experience. But at the same time, on our back end, we are looking at all of those requests, looking at how many of them, looking at where they're coming from, and making a decision. We maybe are using some extra tools like Fraud Guard from Twilio to take a look at those and give us like a suspicious kind of ranking to tell us whether it's good or bad and automatically block and filter some of the bad traffic for us. All right, let's talk about one thing more because remember what I promised about this. I said that you would be able to use one Verify API call for all of your platforms. Now, I'm just going to quickly go into my code. This is the line of code that I'm talking about right here. Just zoom in a little bit. Right here where we create a verification. Now, before we had it as mess, we might have it as a call. We might want to have it as a WhatsApp. I'm going to leave it as WhatsApp for now. And this time when I log in, I should get my message on WhatsApp. Let's see. There we go. There we go. Eventually, it gets there. All right. So now it's on WhatsApp. And what you can do is you can have it over so many different platforms. Oh, sorry, so many different authentication methods. And you can have it so that your user gets to choose, just like GitHub did, gets to choose what their preferred method of multi-factor authentication is. Maybe it also looks at the activity that's triggering this two-factor authentication. And you could do some logic on your own end to say, oh, we should use X form of MFA. And in the end, in your code, you literally have one line of code to change. Pretty simple for you, right? And that should make your life, your dev requirements much smaller, while allowing you to build a secure and safe and enjoyable experience for your users. All right, let's wrap it up. You want to build a complete verification solution. And this is where Twilio is APIs that can help you do that. But remember, whatever you're building, remember to try and use all of these different forms of authentication. Use the bank model to prioritize different forms of authentication for different things, making sure that your application is easy and frictionless for users to use, but hard for any bad actors to get into. Now, if you've really liked what you saw and you'd like to find out more specifically about Twilio Verify, you can check it out here. My colleague Kelly Robinson has an amazing video all about getting started with Verify, where she talks you through how to get it set up for yourself. But other than that, I would just like to say thank you so much for listening. If you have any questions, feel free to hit me up with an email at okenwa@twilio.com, or you can hit me up on the social medias at chatterboxcoder. I love to talk. I love to write code. Chatterboxcoder. That's me. But thanks so much for taking your time to listen to my talk today. Really appreciate it. I loved meeting you folks in person at API Days London. If I didn't get to see you there in person, hopefully I'll see you at the next one. I can't wait to see what you build when it comes to two-factor authentication in your applications.